Right then, question 2. So I just checked my answers to question 1, and I did mess up the show that, and I did mess up my solution to the quadratic equation on that. So quite a spectacular performance from me there. So the ones I just went through in the previous clip I think are correct. So question 2. So these are questions where you're just being required to spot which of the rules you're going to apply: chain, product, quotient. So A, if we let y equals e to the sine 4x, this is one where I've got a function tucked away inside. So I've got a sine function which is tucked away inside the exponential function. Or actually, I've got a 4x tucked away inside a sine, tucked away inside an e. So there's the triple there. But because I've given you the formally in the form sine ax, you can just write that down. So it's a chain rule. So we'll do it the full way, but you don't need to. You can just cover it up. So dy d finger is going to be e to the finger, which is e to the sine 4x, multiplied by the differential of what you've covered up, which is going to be 4 cos 4x. So that's the quick way of doing it. The long way, we'll let u equal sine 4x, which means y is going to be e to the u. Differentiating sine 4x, you get 4 cos 4x. And when you differentiate y with respect to u, you're going to get e to the u, which is e to the sine 4x. So therefore, dy dx will be dy du times du dx, which is 4 cos 4x e to the sine 4x. Okay, so you're basically multiplying that outcome by that outcome. But I've written it that way around just so that it's a little bit neater. You may want to pop that in brackets so you realize that the 4x times e to the sine 4x isn't within the cos 4x, but it's fairly obvious with that one. B. So y equals tan 2x over the square root of x. So this is not an embedded function. It's not a function multiplied by 1, although you could manufacture it that way, but what they're looking for you to do is do it as a quotient rule. So fx, gx, you let u equal the top, so let u equal tan 2x, let v equal x to the power of a half. And it's not x to the power of minus a half, because you're just pulling the bottom term from the fraction. Okay, it would be to the minus a half if you wanted to write it as a product and use the product rule. So now we're going to do du dx. When you differentiate tan, you get sec squared. When you differentiate tan ax, you get a sec squared ax. So this is going to be 2 sec squared 2x. And this is going to be a half x to the minus a half. The quotient rule, dy dx equals v du dx minus u dv dx all over v squared. So dy dx equals v, x to the half, times du dx which is 2 sec squared 2x minus u, which is tan 2x, dv dx, and that's all over v squared, which is basically going to be x to the half all squared. Now the question is saying to simplify your answer wherever possible. So there's some more work that we can do with this. And what I suggest you do is, first of all, write this, get rid of this fractional part here. So x to the half squared is just x, and it's that multiplied all over that. So I could write it like this, x to the minus 1 rather than 1 over x. Then I've got 2x to the half sec squared 2x minus a half x to the minus a half tan 2x. So now I can multiply in this x to the minus 1, and when I'm doing that I'm going to add their powers. So I'm going to have x 2 x to the minus 1 plus a half, which would be minus a half, 2x to the minus a half sec squared 2x minus half, and then I'm going to have x to the minus 1 minus a half is minus 1.5, or minus 3 over 2 tan 2x. So that's simplified it a little bit, and you could probably leave it like that, or you could multiply by 2 over 2, which would get rid of, what have I given the answer as? Let's have a look. So I got the half there, so I left it like this, 2 x to the minus a half sec squared 2x minus a half x to the minus 3 tan 2x. There we are. So that's as far as I've taken it, so that's fine. And then part 3, y equals 3x to the 4 cos x squared plus 2. So I haven't got a quotient, I haven't got a fraction, but I've clearly got one part there which is being multiplied by that part there. So this is going to be a product rule where u is going to be this bit of it. So going back to what I'm telling you here, if I got one function which is being multiplied by another function, so I've got fx times gx. Cos, that's a function in its own right. 3x to the 4 is another function. So I got 3x to the 4, and then v is cos x squared plus 2. So that's a cheeky chain rule. Okay, that x squared plus 2 is tucked away inside that. So I'm going to need the chain rule to deal with that. But this is a straightforward du dx equals 12x cubed. So dv dx, so because it's a cheeky chain rule, I'm just going to do it straight off. So cos a finger is going to be minus sine a finger, multiplied by differentiate your finger, differentiate what you covered up, which is going to be 2x when I differentiate that. So that's going to be minus 2x sine bracket x squared plus 2. Now we build it. dy dx is v du dx plus u dv dx. So v cos x squared plus 2 times 12x cubed plus u dv dx tidy up. So first of all, let's just write it a little bit neater. So I'm going to have 12x cubed cos x squared plus 2. Now when I multiply this out, I'm going to have minus 6 x to the 5 sine x squared plus 2. I can see I can take 6 out as a common factor, and I can take x cubed out as a common factor, which will leave me 2 cos x squared plus 2 from that first term. So if you multiply that by that, you get back to that. And then the second term, the 6 comes out, leaves me an x squared sine x squared plus 2 in there. There's nothing else really you can do to simplify that. Just me checking whether I get it right. Oh, I didn't even bother going that far in my answer. So I've left it as 12x cubed minus 6x to the 5. So there we are. I don't think it would really matter. That's not necessarily any more simple than that, unless you're going to go and do anything else with it. Then we come to B. So 3b, a function is defined implicitly. So this was the other differentiation skill that we practiced. So an implicit function is one that you cannot rearrange to write it in terms of y equals a function of x. You probably could just about with this one, although you'd end up with a plus or minus root in it. So, but that's not the way that they want you to solve this. So when you differentiate it, which we're going to need to do, because it's another question where we want an equation of a tangent or a normal, this time it's the tangent, so we need the gradient function. What we do is we differentiate each term separately with respect to x. So that's that term. That's that term. That's that term. And that's that term. Now when you differentiate x with respect to x, that's easy. So that's a straightforward 2x. When you differentiate a y with respect to x, that's where it gets a little bit more complicated. So for this bit, this is where the extra skill comes in. And in the assignments that I set you where you had an implicit function, you weren't liking this. So this is a product rule. So we let u equal 4x, and we let v equal the y squared. I can differentiate this with respect to x and get 4. Now remember, I'm differentiating with respect to x, so I'm not doing dv dy here. Oh, I'm not doing it, he says, and then he writes down dv dy. I'm differentiating it with respect to x. And if you think back to when we were doing this, and I won't go through all the theory now, when you differentiate y with respect to x, you differentiate it with respect to y, but then you multiply it by dy dx. So this is the implicit differentiation skill that it's worth going back into your notes and checking. Then I rebuild it. So it's v du dx, which is that times that, for y squared, plus u dv dx, which is that times that, which is going to be 8xy dy dx. So v du dx 4y squared, u dv dx 4x times that is going to be 8xy dy dx. When I differentiate the 2x, I just get 2, and when I differentiate the constant, I get 0. So rebuilding all of that information into equation 1, all in 1, I get that, which is 2x, plus this, which is that, 4y squared plus 8xy dy dx, minus 2 equals 0. And what I'm looking for is to get the dy dx on its own. I can divide throughout by 2. Just to make it a little bit easier. I want to keep the xy dy dx on the left hand side because it's positive. So I get xy dy dx equals minus 1, take that over, it becomes positive, minus x minus 2y squared. That's a 4xy. So I get 4xy is 1 minus x minus 2y squared. So dy dx equals 1 minus x minus 2y squared over 4xy. If you're uncomfortable dividing throughout by 2 there, just leave it as it is. It doesn't matter. It'll all come out in the wash when you actually evaluate the value. So I now want the equation of the tangent at 2, 1. So tangent at 2, 1. I need the gradient. So x is 2, y is 1 over 4 times 2 times 1. So 1 minus 2 over 8 equals 1 minus 4 minus 3 over 8. So now y minus y1 equals m x minus x1, y minus 1 equals minus 3/8 x minus 2. I'm going to multiply by the 8 to get rid of the fraction. So that will give me 8y minus 8 equals minus 3x, multiplying that out, plus 6. So 8y plus 3x equals, bring that over, positive 8y plus 3x equals 14. What have I got for this one? Oh, look at that. 8y plus 3x equals 14. Hurrah. So that's question 2.